There is a controversy about Greek and Indian astronomy. So what happened was when Britishers came to India in 1700s, 1800s, and they saw that the Greek and Babylonian zodiac, that would be the 12 uh, Rashis in India, they used to call, and that was same as the Babylonian zodiac, that was also 12, and the Greek zodiac, and it was obvious that the Greeks took it from the Babylonians. But where did the Indians got it from? Did the Greeks get it from the Indians, or Babylonians get it from the Indians, etc.? And then also they saw this theory on astronomy called Epicycle theory appearing in Indian astronomical book like Surya Siddhanta, Paitama Siddhanta, etc. And they were somewhat similar to Ptolemy's epicycle theory. So the big question was, who took the epicycle theory? Did Indians came up with the epicycle theory and went to Greece, or Greek took it from the Indians? So this issue was discussed for a long time, and one of the classic papers on this issue was David Pingree, professor in University of Brown, and this is called On the Greek Origin of the Indian Planetary Model Employing a Double Epicycle. So I'm going to go through this paper, and in my opinion, I should say, David Pingree was somewhat biased, but that doesn't mean his points cannot be just thrown out. I mean, he has good points, even though his opinions are biased. And then I'm going to go through other papers, like S.N Sen paper, let's see here. And this paper by Subash, someone named Anil Narayan, I would go through that. And then I would also go through a very good paper by S.N Sen. S.N Sen considered to be a authority on this subject. Epicycle eccentric planetary theories in ancient and medieval Indian astronomy. And his paper is good. And I would go through, and then end of the day, you could make up your own mind whether the Indian astronomy, the Zodiac, the epicycle theory, the retrograde motion, these are the double epicycle of the Indians, and various epicycles were employed by the Indians. Same as Ptolemy. Ptolemy also had epicycle, but he never had the double epicycle. So this paper by Sen, and I would go through his paper, and also Subash Kak's paper, and then you would be able to make your own judgment whether astronomy, the planetary motions, the planetary astronomy, mathematical astronomy, which is known as Graha Ganita, came to India from Greece, or Greece took it from Indians. So that's the journey we are going to take. And first I'm going to look at the Pingree's paper, David Pingree. He's a Sanskrit scholar. He read the Sanskrit public books by himself, and he collected 100,000 Sanskrit documents and preserved it, and that's immense service to Sanskrit scholars. And then I would go to the Sen paper, Indian scholar. He's also a Sanskrit scholar. He knows Sanskrit, and he could read the ancient books. But then there are other scholars also who are not Sanskrit scholars, but they refer from other papers and try to put together their own version and put together a story. And they don't have, like Subash, he don't know Sanskrit. At least he cannot read those books. And same thing with Anil Narayan and various other scholars. What they do is they would go through the papers by Sen and Pingree, and Vander Warden is another Sanskrit scholar. Bina Banerjee is another Sanskrit scholar. And there are a bunch of people there's not many people who can read these astronomical texts in the original text. Kim Flofker is another one who can read them, who is a Sanskrit scholar. And there are few like Billard, Vander Warden, Billard, Pingree, S.N. Sen, Banerjee. These are very few people who can read these Sanskrit documents. And most others, what they do is they would pick up information from these scholars and they try to come up with a narrative on their own. And there's nothing wrong with that. So we are going to go through all these papers, and then you would be able to make up your own mind. So let's start with the Pingree paper on the Greek origin of the Indian planetary model employing a double epicycle. Now I'm going to read important parts of this paper. I'm not going to read the whole thing, and then I will try to explain. So let's start. The development of geometric models to explain the inequalities of planetary motion in terms of combinations of circular motions is characteristic of Greek astronomy and derives its initial bias from statements of the Pythagoreans, Plato, and Aristotle regarding the structure of the universe. In the case of Aristotle, the difference between the mechanics of the sublunar center of the cosmos and that of the celestial spheres. So what Pingree is saying is that before the Greeks, people were looking at the sky and they saw that the stars, the constellations, moving every day around the earth. So they thought that the sun is, earth is at the center. So I have these documents here. So they thought that the earth is at the center. But we know today the sun is at the center. But they thought that the earth is at the center. But what they saw was that these constellations going around the earth, and then they saw that some of these little ones moving in certain directions, that would mean that they were moving with relative to the stars. The stars were fixed. They were not moving among themselves. But these other ones, they were called wanderers, the planets. They move from, so Moon and Venus here with relative to here, and then Moon and Mars. Moon has moved to this area, and that motion was known to Indians, Greeks, and Babylonians from very early stages. But there was a problem. The problem was that these motions were something like this. They were moving like that. They had a zigzag motion with relative to the background stars. So Babylonians came up with this zigzag function. They came up with an arithmetic function that would explain the zigzag motion of these planets relative to the background stars. So let's go back to what Pingree is saying here. So this zigzag motion has to be explained. The development of geometric models to explain the zigzag motion and he called it inequalities of planetary motion in terms of combinations of circular motions is characteristic of Greek astronomy. So the Babylonians had this zigzag function to explain this motion. They had an arithmetic function, but the Greeks came up with this idea. They said, here's the Earth at the center, and they said there is a circle that was called the different circle. So this big circle is called the different circle. And there's another small circle which is called the epicycle, and the planet is moving in the epicycle. So the planet is moving in the epicycle. The epicycle itself is moving across this. So this is a geometric model. What the Babylonians had was a arithmetic function. They had arithmetic function that if the planet was at this position, they didn't have the coordinate system, but they had taken the distances from the ecliptic. Now, I would assume you know what ecliptic means. Equatorial circle in the celestial sphere and the ecliptic. These two things are known to Babylonians. Maybe I would do another lecture or webcast explaining these preliminary stuff. But I assume you understand the equinoxes, the vernal equinox, the solstices, ecliptic, and the equator. So anyway, with relative to the background stars, they were able to see this zigzag function, and they came up with a mathematical arithmetic function. But the Greeks, I think everybody agrees, Greeks were the first to come up with this, some kind of a geometric method, and where you have a circle, where you have the Earth at the center, and then you had a circle, and there's another epicycle. So this was mostly done by the Greeks. So let's go back here. So let's read it again now with that knowledge. The development of geometric models, that would be the models using epicycles, to explain the inequalities of planetary motion. Inequalities of planetary motion means zigzag motion of planets with relative to the background stars in terms of combinations of circular motions. That would be the different circle. That would be combination of background stars. So we had a different circle, combinations of circles. So the different circle and an epicycle. The epicycle moves around the different circle, and the planet moves around the epicycle. So Pingree is saying that these epicycles is characteristic of Greek astronomy and derives its initial bias from statements of Pythagoreans, Plato, and Aristotle regarding the structure of the universe, and in the case of Aristotle, the difference between the mechanics of the sublunar center of the cosmos and that of the celestial spheres. So what happened was, there was a debate. The Pythagoreans said one thing, and Plato said one thing. Aristotle said something called sublunar space, which he thought that the atmosphere goes all the way to the moon, and beyond that there is no air. And also Aristotle said all the planets move in a circle around the Earth. And he said that the Earth is at the center of these planetary motions. All the planets move around the Earth. Everybody agrees on that. Everybody agrees. Plato, Aristotle, everybody agrees. But Aristotle added another ingredient. He said the planets move around a circle and the center of that circle is the Earth. What Aristotle said was, according to Aristotle, planet was moving in a circle, and the center of that circle is the Earth. But this did not work. This could not be made work. That zigzag motion cannot be explained using this. So that's why Ptolemy adopted this epicycle. So the planet is not moving around the Earth as the center. Planet is moving at a center here, and that center of the epicycle moves around the Earth, and that's what Ptolemy said. Then that is against Aristotle's logic. And he also introduced an eccentricity, which we will come into that later. And this is the zigzag motion which we talked about. So that's what Aristotle said. So let's go back. And it is hardly necessary to point out here that among the devices invented to account for these inequalities are the eccentric circle and the epicycle, whose properties were investigated by Apollonius about 200 BC. Now what he is saying is that now there's a new concept here, eccentric circle. Okay, let's see what that is. So this is the original model. You had a circle, and then you had an epicycle. The epicycle goes around this circle, around the center of the epicycle goes around the Earth. The planet goes around the center of the epicycle. This could not be made work. It was not explaining the planetary motions. So they have to come up with another idea. They said that Earth is not at the center of the different circle. Earth is somewhat away from the center of the different circle. So the center and the Earth, where we observe, is at a distance called E, the eccentricity. So that way they could come up with little better model to explain the planetary motions. So they added an eccentricity. So the Earth is not at the center of the different circle. Now this is totally against Aristotle's logic, because Aristotle said, now Aristotle is a guy who did not do any experiments. He just sit around and he came up with these ideas. Sometimes he's right, sometimes he's wrong. So, but his ideas had a lot of impact, and people didn't want to go against him, except Ptolemy and a few others. So, according to Aristotle, Ptolemy's model is wrong, because Aristotle said all the planets going around the circle, and the center of that circle is at the center of the Earth. But that's not the case here. Ptolemy had an epicycle. The planet is going around the center of the epicycle, and the center of the epicycle going around a different circle. And that circle, the center is not the Earth, but the Earth is at a distance called E, the eccentricity, away from the center. So now this is totally against Aristotle's logic. And this idea was provided by someone, one great mathematician, also an astronomer, Apollonius. So the occurrence of these devices, that would be the eccentricity and the epicycle, in Sanskrit astronomical text of the 5th century AD, immediately suggests some Greek influence. Now these epicycle theory originated in Greece around 200 BC, Ptolemy around 100 AD, but they did not appear in Indian literature till 500 AD. So Pingree is saying, so two things could happen. This epicycle theory could have Indians could have developed by themselves, or they got it from the Greeks. And the Pingree is saying Indians got it from the Greeks. That's what Pingree said, and we will see. Now, of course, some Indian scholars agree, like S.N. Sen agrees that with Pingree, that this epicycle and the eccentricity, these ideas came from Greece, but they developed further into something different. But some scholars like Subash, Anil Narayan, and some others, they say that epicycle theory was in India way before Ptolemy and Apollonius. And so let's go back to the Pingree paper. And the supposition of such an influence is greatly strengthened by the fact that Greek adaptations of Babylonian linear astronomy, that would be the zigzag motion, that they had a function, and Greek treatises on genealogy were translated into Sanskrit between the 2nd and 4th centuries AD. What is genealogy? Genealogy was that in Greeks they had this art. When a child is born, they would predict what that child is going to be. Whether that child is going to be a doctor, a king, or a laborer, whatever. That's the art of genealogy. But then it occurred to me, when Lord Buddha was born, that there were predictions made by various Brahmins, and that one Brahmin said he's going to be a king, another one said no, he's going to be a religious leader, etc. So at 500 BC, the genealogy was in India also. Now, I don't remember where that story appeared. It's not in any of the sutras, but it's in another book. So I had to find the dating of that book. So, but genealogy, according to Pingree, came from Greece to India, and 2nd and 4th centuries AD. But we can say it was in India before that, because that Buddha story has to be way before that. But I don't have the dating of that book, which I have to look in when I get a chance. And then Pingree goes, it is virtually confirmed by the fact that the earliest Sanskrit Siddhantas to employ epicyclic model, the older Romaka, for the luminaries only, the two luminaries are the sun and the moon, and Paulisa Siddhanta and the Romaka Siddhanta, and that would be only for the sun, are largely of Greek or Greco-Babylonian origin. It is my intention here to investigate the Greek background of the common Indian model for the star planet, which involve two concentric epicycles. Okay, let's see what he's saying. There are two Siddhantas dated to 500 AD. One is called the Romaka Siddhanta, and the other one is called the Paulisa Siddhanta. And the Romaka Siddhanta and Paulisa Siddhanta were considered to be of Greek material translated to Sanskrit, and some people think that there were Greeks in India who came with Alexander the Great, and they wrote these books for their use, and they are highly Indian and Indian characteristics, and there are Greek characteristics, and there is a mixture of both Indian and Greek astronomical ideas. But definitely some Greek ideas are there, and that I think everybody, all the scholars agree on that. But the disagreement is how much in these Siddhantas were Greek and how much was Indian. But they are of Greek origin, Paulista and Romica Siddhanta. And then he goes on to say, in another Siddhanta called in Paitama Siddhanta of the Vishnu Dharmottara Purana, which is our earliest extant exponent of the Indian double epicycle planetary model. It was probably composed in the first half of the 5th century AD. Now, Indians used two epicycles, double epicycle planetary model, which was never seen in Greek text. So, what does that mean? Does that mean Indians developed, a number of things could happen. Indians developed the whole epicycle theory by themselves, or they took the Greek one epicycle theory, or Greek had many epicycles, but it was a different context. But we will get into that. So the Indians took the Greek epicycle theory and further developed into a double epicycle, or Indians developed the whole epicycle theory by themselves. So that's the question we have to look into. But what Pingree is saying, that the Indians took the double epicycle theory also directly from the Greeks, and that's his theory, which we going to see what he's going to say in the paper. And I'm going to take a break, and then we will go into the part 2 and for the next part. So before I go, I will do the summary. So what Pingree is saying, that the geometric models to explain the planetary motions. So the planets were moving in a zigzag motion relative to the background stars. And the epicycle theory, the geometric models were first appeared in Greece, in Apollonius and Plato and Aristotle and all these. And I think that everybody agrees on that. There was no epicycle theory 100 AD in India. Epicycle theory first appeared in India 500 AD. So everybody agrees on that. But India had double epicycle theory, something like this. They had two epicycles, and in some places another one here, another one here. So this type of thing did not appear. We are going to look into mathematics of it. This type of thing did not appear in Greece. So it could be Indians took the single epicycle theory and made it to double epicycle, or Indians developed the whole epicycle theory by themselves. But then how you explain the two Siddhantas, and there are more than two Siddhantas, that came from Greece or had Greek influence. So that's the question that you have to look into. And I want to say something about this double epicycle. Now Ptolemy had epicycle like that, and he put another epicycle on top of that, and he went up to 40 epicycles, 40 some locations. But he didn't have two epicycles in the same different circle. So he had epicycles on top of other epicycles, but not on the same different circle. That was never appears in Greek astronomical book. It's an Indian invention. So it's good time to take a break, and then I will see you in part 2. Thank you very much for listening.